Hi, everybody. Thank you for joining us today. We'll wait a couple more minutes to let everybody come in, and we'll start. Perfect. It seems like most of the people have joined us, and whoever hasn't joined us will come in later. So, hi, everybody. We're very excited about this digital event and believe the topic discussed is one of the most significant ones at hand in our ecosystem: how to scale beyond visual line of sight autonomous UAV operations and enter the new era of unmanned aerial services. So the agenda for the event, I'll give a short introduction to the companies speaking today and a little bit about the topic. Then we'll have about 40 minutes of a speaking spotlight by our respected panelists that joined us. And at the end, you'll have a Q&A session that you'll be able to send in questions through the QA feature on Zoom, or also you can raise your hand and I can unmute you so you can ask a question live. So let's jump right in. So 2020 has given us many major milestones for the UAV and UAS ecosystem, with manufacturers expanding their offerings to support the needs of the market, regulators globally opening up the skies for beyond visual line of sight flights, and many use cases emerging, including COVID use cases, but not limited to them, transforming autonomous beyond visual line of sight UAV operations with whole solutions for the ever-growing challenges. With that being said, the autonomy and connectivity challenges deemed to be the barrier to scaling autonomous beyond visual line of sight operations to commercial levels, especially in the eyes of operators, regulators, and of course, manufacturers. To expand on this topic, I would like to introduce our respected speakers, Shai Levy, the CEO of FlightOps, and Yoav Amitai, the CEO of Elsight. FlightOps enables autonomous multi-UAV operations using C2 and air traffic management. The FlightOps solution is certified for urban beyond visual line of sight flights and operates as an integrated airspace management system. Elsight provides reliable, safe, high bandwidth, low latency UAV connectivity through its latest product offering, Halo. Halo is an OEM connectivity platform which is beyond visual line of sight certified, supports unlimited range of operations, and is integrated into UAVs around the globe. Without further ado, Shai, Yoav, the floor is yours.
Thank you, Asaf. Hi, everybody. My name is Yoav Amitai. I'm Elsight CEO. And before we are jumping into the topic, I would like to speak a little bit about the industry. Asaf, if you can turn the slide, thank you. So speaking about the drone industry, basically is built of three main sectors, starting from the consumer, then the enterprise, and the government sectors. And when we are talking about scaling, obviously we are talking about more of the enterprises and the government's application, and not only not the consumers, because if we're looking at it from the industry perspective, we would like to grow and make it something very big, and to do that, we can't rely on the consumer level. We would like to take it into the commercial level to create the business cases and everything that will make this industry grow, basically. Now, when we are talking about industries or what is incorporated, what are the use cases inside the industry, or rather the industries that currently utilize the drone technology, we can mention a couple of them, but the list just go on and on. I saw the other day an article showing 180 different use cases for drone operations. Here I will mention the industrial, speaking about inspection and maintenance for grid lines or for big operation facilities. Speaking about agriculture, so it will be precise agriculture to do the spraying for your field if you want to do it ad hoc and not going for the whole field, and make it much more cost effective. Insurance, so if you're talking about creating better risk management through improved data collection, analysis, and actionable insight by 360 degrees analysis. So having a drone there can help you as well. And obviously speaking about the delivery, it's probably the part of the biggest one that is the easier to understand, doing just deliveries either for food, groceries, drugs, healthcare, and all those sort of stuff that can leverage this technology. Last but not least, where everything is started is the defense and homeland security, for security purposes, for defense, for many different kind of use cases and application. And like I said, the list goes on and on. Personally, I believe that what we currently see is only the tip of the iceberg, and we are, as an industry, are in very exciting times of where it can take and where it can go. Now, before going into the Bvlos, let's understand first what are the terms or what we're looking at. So what you see here on this slide is according to the FAA regulation, what is considered visual line of sight, what is the extended visual line of sight, and beyond visual line of sight. Now that is very important to understand, because on the visual line of sight, where you are limited from 0 to 500 meters around the operator, it's not something that you really scale. I mean, there are a lot of different the extended visual line of sight. We're talking about 0 to 3 kilometers operations. And again, it's something that is still limited, and somehow we need to extend those limitations. And not only the limitation, but also the fact that on the visual line of sight or extended visual line of sight, we need to have one operator for each one platform. Now, even if we have an operator with an observer that can go to 3 kilometers, or even if he can operate more than one drone, it's still very limited. And we're switching to Bvlos. Now it's time to understand what the Bvlos is. So literally beyond visual line of sight, going from 3 kilometers or from 0 to any range that you would like to operate with the platform. But even more important than that is speaking about the autonomy, or the ratio between numbers of operator, if operator at all. Shai will extend on that later on in the presentation, to many platforms that are in the field. So again, going back to, if we want to scale and we want to create something that will have a business case, first we will need to go for very long distances. Second, we need to make sure that one operator or no operator at all is needed to be able to enable fleet of drones doing their operations or their tasks. And to do that, we will need to look into the Bvlos, and this is why the Bvlos is so important. Another point on that will be on managing the airspace. And this is another something that is getting into the Bvlos, and think about an airspace that have different applications, different use cases, from Part 107 or Part 135, from logistics to security to inspection, etc., etc. Everything is located pretty much on the same airspace, and that needs to be managed. And this is also part of the whole Bvlos approach that need to be solved to make this whole industry grow basically and go forward. Now, what is a scale? When we're talking about scale, it's important to bring the drone industry into economy of scale. And where are we at now? Just a brief of where we have been and where we are going to. So currently the industry is huge. I mean, if you're looking from the drone industry as a whole, not only on the enterprise level, but also on the hobbyist level, it's very big economy. But we can get it into enormous sizes. And just to give you some numbers, according to PwC, like they put it, the emerging global market for businesses services using drone is valued at over 127 billion US dollars in few years to come. Now, just to give you some reference, the automotive industry today is about 2 trillion US dollars. So it's only 1/10 of it. And in that manner, I think, or as I see it, we are in the middle of an history. We are living the history right now, like the automotive industry had in the early 1900s, when the vehicle just started to go on the street, and we have a lot of challenges there. We will talk about regulation and everything. We are currently living this, and to make sure that we can scale and everything, or we can create a business case, there are several things that we need to solve. Now, together we will need to create a business case, and that is why BVLOS is a must, like I said before. The drone industry will first remove people from dangerous work. We reduce the number of people that needed to know people at all to be fully autonomous. Shai will elaborate on that. Reduce the number of steps that in the process from something needed to happen until it's done. Replace other costly methods of using helicopters, using fleets on the ground, etc., etc. You want to reduce this cost to make, like I said, business case. This is the name of the game if we would like, as an industry, to grow and to get into enormous sizes. And access is inaccessible by human location. And last but not least, perform tasks quicker and much more efficient. And this is what the drone industry bringing. By the way, when we're talking about drone industry today, we are very focused on the aerial vehicles, but it can get anywhere. It can get on the ground, in the water, etc., etc. So just what stops us, or what will take us to the next level. And again, I will go to the example I gave with the automotive industry, that 120 years ago just started to have vehicles on the street, or little earlier than that, and then regulations come in. Now, we're living the history where we have the technology is mature enough, is robust enough. We will talk about it again a little later. On one hand, on the other hand, we need to put the right regulation to make sure that everything is managed correctly, and we can manage delivery drones going from hobbyist drone, from commercial flights, standard flights in no flight zone. I mean, everything needs to be managed, and the regulator needs somehow to understand how everything can be managed. And this is exactly what the industry is doing together with the regulator, bringing us into a phase that we will have the enabler from the regulation, because the technology is already there and working, basically, how to take it into the next phase and being able to go into the economy of scale. And Shai will elaborate on that.
Hi, everybody. My name is Shai Levy, and I'm the CEO of FlightOps. When we're talking about the economical scalability, which basically today still is stopping us, well, the need to make profit from your operation is probably the first thing that will encourage growth in the industry. And this growth should be, or will be probably based on operating multiple UAVs or multiple drones in a beyond line of sight, or in large distances, such as for deliveries or for agriculture. And this is a challenge. And another challenge in the business that actually stops us is the fact that we need to coordinate the missions in real time most of the time. If you want to deliver 1,500 corona tests per day, then you need to coordinate the flight missions, and manually coordinating it as it is mostly done today with pilots in the loop is a very challenging process. So in order for the economical scalability for the operation to be economical, it needs to be scalable, and according to that, we need the supporting system to do that. So what are the challenges in BVLOS operation management? So first of all, in order to get beyond visual line of sight and to take the pilot out of the equation, you need to add autonomy to the platform. The platform has to deal with its managing its energy. It has to deal with managing possible malfunctions. It has to find its way around the restrictions, and it has to avoid ground obstacles and other things along the way. So autonomy is highly important in order to move into BVLOS operation. Another issue that has to be dealt with is robust connectivity. You need your drone to be connected at all times as much as possible. Although you have autonomous systems, you still need connectivity to monitor, to provide spatial information, ground information, airspace information to the drone to make its own decisions in the airspace. And connecting all of this is the airspace management system, or the UTM system, or any way it's called around the world. But the thing is that drone operations are going to grow to hundreds and thousands in the same area, thousands of drones flying in the same area, and there has to be a method and a way to coordinate the operations between all of them. So these are the three building blocks, or the three elements that makes BVLOS operation possible. So when it comes to choosing right OEM partners for BVLOS and for economical operation, well, the first thing you would have to ask yourself about incorporating any technology: does it shorten the path to certification? Is it certifiable, or has it been proven to be certifiable anywhere in the world? Is it adding to my solution robustness? Does it enhance the safety of my platform, or is it reliable enough to enhance my capabilities? Another issue is the performance enhancement. Each technology you want to add to your platform should add more capabilities for your platform, meaning, or your operation, meaning you can access more markets, you can do more things with your platform, and it should have to be a scalable business, adding more drones, adding more distance to your operation with simple integrations. And in addition, another thing is the flexibility of the system. Can you customize it to your exact business process? Can you expand in business segments, and can you add more use cases or use scenarios to your business? So it's all concluding at time to market. If you add the right technology, or add the OEM technology, then it should reduce your time to market. So another question we're asked all the time, and we're asking ourselves, is where does the regulation is headed? We see two parallel paths. One is the technological advancement. In the past few years, we're getting better platforms, better system to support these platforms, we're operating in longer distances, and we are operating with lower risk, with enhanced safety and robustness for the system. We see it as a gradual process, and we're in it together. And another thing for the regulator is the knowledge and confidence. Regulators accumulate basically knowledge and confidence in the systems that they certify, flying more hours and more distances, and with thousands of sorties. So these are all issues that the regulator has his attention on. We see that SORA, the specific operation risk assessment, is going to be the basis for future, is currently the basis for certification, but it's going to continue to be the basis for certification. We see that the regulators would prefer to certify well-defined operations, either well-defined areas and well-defined systems and well-defined platforms that they know and they accumulated knowledge and confidence in. And we think that it should be we should be following the proven certification methodologies, as I mentioned, the SORA at the beginning. So these are all things that are the regulation is headed to. Okay, so when we're talking about scaling Bvlos autonomous UAV operation, we're talking about four sections or four things. First of all, if you want to scale the Bvlos autonomous operation, then first of all you want to operate multiple drones in order to make profit. Let's say it's not logical to operate one drone in delivery process. You want to operate tens and hundreds of drones doing deliveries. This is the only way you're gonna make profit out of it. So operating multitude of platforms is an important key factor. Another thing we mentioned before is the shared airspace management. You're operating all these drones in a shared airspace, and you would like to do it with a single or no operator, or at least much less operators than the number of the drones you're operating. The next thing is the automation, or it should be automation and integration. First of all, the mission planning capability should be as automated as possible. If you're delivering goods, so you want the delivery system connected to your flight operation, and in this way streamline the process from the warehouse to the customer. Same way as platform assignment, you want an automated system to pick the appropriate and ready platform for takeoff that is in the right location with enough energy to reach the destination. So it should be automated as much, and automate the safety and monitoring of the system, checking all the time the validity of routes, checking all the time the status and health of the platform, and making this automated decisions as what to do with the platform at any stage. The third point is the flexible capabilities. You want your system to be flexible. We talked about it. You want it to be easily integrated into other systems. You want to add features to your system. Let's say tomorrow you get a new sensor that requires a different behavior for the system. You want to have the opportunity to change this and adapt it to your business process. And this all helps you deliver business value to your customers. The last point would be the geography point. First of all, as we discussed BVLOS, and we mentioned that you should not have any range limitation using LTE communication or other communications that enhance your range. First of all, the range to fly from the places you took off, and second of all, the ability to operate it from anywhere around the world. We had this today. We were sitting in the office and flying an operation 100 kilometers from us. It's so this is very important to control all the geography. Another thing is the DTM and DSM. Your system must be aware to the ground because we're flying relatively close to the ground. We're talking about from 50 meters to 120 meters usually. So there's buildings, there's mountains and hills, and you should be aware of them. When flying long distance, this is an issue from the system, and on the same weight, we're talking about flight restrictions, such as no fly zones. Should avoid entering restricted areas such as airfields, etc. Okay, so now when we're talking about the Elsight and FlightOps solution, first of all, we need to understand that you get this solution out of the box, integrated, and it allows it is a certifiable solution. We have certified it here in Israel, and it flies beyond visual line of sight in urban environment. So first of all, you need to understand that the idea is you can integrate it very simply to your platforms, and I will elaborate on that later on. And what you get on the FlightOps side, at least, it is the onboard autonomy. We basically add an onboard computer or onboard software that turns every simple drone or every flight control system into an autonomous mission-aware robot. We have a mission management facility that helps you manage your missions, either create them through a user interface or link it or integrate it to another business system. And we have the UTM system, or the airspace management capability of the system, that allows you to operate a large number of drones in the same area, all together with external users or external operators operating in the same area as well. Yeah, Yoav.
So as we've been talking in the last 25 minutes or so, Bvlos is built of two main building blocks. First is the autonomy part of it, like Shai just mentioned. This is FlightOps part on this offering, and on the other side, we're talking about robustness, unlimited basically capability to do any operation without a limitation of distance. What we're doing in Elsight, our part is the connectivity part, which enables both very high availability and always on connectivity and the unlimited. So what we're doing, we're incorporating into our device, which is tiny form factor in terms of communication device or link, multiple IP links, including cellular, multiple cellular. If you will have on your platform, you can add to it also point-to-point communication or satellite communication if you have it on board. And we are basically, what we're doing, we are orchestrating all those networks together to make sure that your drone or your platform will be always connected either with the C2, with the operator, whatever you want to be connected with. We will be the one that create the link. Now, because we are utilizing multiple IP links, it's not only that you're getting this robustness, you also get several other values out of this same technology out of the box, like Shai just mentioned. First of all, the bandwidth. So think about different use cases that have different payloads on board on the platform, and you want to deliver high amounts of data, either for LiDARs, for cameras, any other payload that you have on board, and you would like to take it to the cloud or to the pilot. You have our high bandwidth solution that, by utilizing all of the networks that I mentioned before, will create a high bandwidth link that you can just deliver through it big amounts of data. Not only that, but also the security. When we're talking about wireless, we are also always concerned, about security and making sure nobody will hack, nobody will manipulate, nobody will do anything with the communication from the C2 or the pilot to the drone. And this is also something that it's built into our solution. Now, combining both of those solutions together in a form factor that can get into almost any size of drones, from the small one to the biggest one, and connecting, Shai will elaborate more on that, but just connecting very easily the platform to the solution, and by that getting both the autonomous part of it and the long-range robust communication part of it will make you get into the market, like Shai mentioned in his part, much faster.
So, as mentioned about the integration or the ease of integration, it's an extremely simple process. Because we are already integrated FlightOps and Elsight. It means that the FlightOps onboard computer integrates to the autopilots, either Pixhawk, just connected to the telemetry port with a single connector, or either the DJI or A3 autopilot connecting through the API port, or connecting to additional, such as UAV navigation or embention or whatever autopilot that we are already integrated to. It's as simple as just connecting a connector into your autopilot and finding and bringing the energy to the whole communication and onboard computer, and that's it. You're in, and all you have to do is just register to the FlightOps cloud system, and you have all these abilities built into your platform. An additional thing is that you can benefit from all the certification documentation that we already have, and thousands of flight hours, recorded flight hours that would help you certify your solution.
Perfect. Thank you very much, guys. This was actually super interesting insight into the industry. Obviously, many factors come into consideration when speaking about scaling autonomous beyond visual line of sight operations. And now I would like to jump to right into the QA session. We do have a couple questions here that are written down. I will also open the options for all of the attendees right now to be able to speak with us live. If you want to ask a question live, you're more than welcome to do that. So we do have a first question from Denzel. Denzel, if you want to ask it live, you're more than welcome to do so. And if not, I can read it out. So Denzel asked us, what flight controllers can you connect to with Elsight?
Just like Shai mentioned, and you were talking about the mutual components, but take the same for Elsight, using with any flight controller. Shai mentioned the DJI controllers and the and the
Pixhawk.
The Pixhawk controller. Thank you, Shai. But basically, with the communication part of it, you can look at Elsight solution as a very long LAN cable that will connect from the platform to anywhere you want on the other side. So basically, we are agnostic to the flight controller.
I want to add to that. We're currently integrated to Pixhawk either through Mavlink directly or through Pix4. And we're integrated into all of DJI Matrice family flight controller, either the Matrice 300 or the 600 or the 100 and the 200 family. So in addition, we have some higher grade flight controllers such as UAV navigation and Unmanned that we're already integrated. But the thing is that any new flight controller or any other flight controller that is brought to us, we can integrate in a matter of 2 to 4 weeks tops. This has been our experience in integration.
Thank you very much, guys. We have another question from Adrian. In case of relying on LTE and later on 5G and similar network platforms, how do you secure a handover from one operator to another? So it's from one operator to another and also from one telecom provider to a different provider, which is not telecom.
Great question. Thank you, Adrian, for the question. Maybe I will go a little deeper into the technology of how we secure those links, or how do we orchestrate all those links together, and that will be the perfect answer for this question. So basically, what we're doing, we are utilizing all the networks concurrently. So it's not that we are having one SIM card on board in the case of cellular, for example. So we have 4 different cellular modules on board, which work completely in parallel to each other. So in the example of the North America or the US, you can have their onboard Sprint, AT&T, Verizon, T-Mo, inside your platform, and all of them will work concurrently. It's not like we're doing redundancy, we are utilizing them, all of them together. Now, it doesn't really matter for our algorithm if one of them will work on 2G, 3G, 4G, or 5G when it will be available enough. So we will utilize all of them, and this is the core of the value of the communication product, is how to utilize them all together. I will maybe give another example that will emphasize it maybe even more. Is an integration we did with one of the platform manufacturers. They had their own point-to-point proprietary network communication. So what we did, we connect that into our module. Then we leverage both the multiple cellular and their point-to-point channel. And when the operator or the pilot flies the drone, starting from 0, then it will work until it will get to the edge of the network, the point-to-point coverage. Once it's turned into a cellular, the pilot don't even feel it. I mean, it's happening automatically and very smooth. And this is exactly the head of the technology. I hope I answered the question. We're not really handover, we're using all of them together. And if some of them failed, we will just automatically track it and we'll continue to work with the other ones.
Alan, I see that you want to ask a question live. You're welcome to do so. Okay, we have another question from Teresa. Teresa asked if we can elaborate on the connectivity. Is it a 5G solution? Is it 5G ready?
So another question, and our approach about the 5G is a little different than the rest of the industry. But what I would say is that currently the device is 5G ready. We are looking in the first quarter in 2021 to have the prototypes or start to shipping prototype for customers to test it with 5G. And our approach, like I said, is the main thing that is important or the two main things that are important for the unmanned industry is, first of all, reliability, making sure you're always connected, and obviously latency and throughput. Now, speaking about the latency or throughput, 5G is something that we are all as an industry waiting for and looking for to make many other use cases that we can't even imagine. Like I said at the very beginning, we are only on the tip of the iceberg. But the one thing that it won't solve is the reliability. Now, think about aggregating more than one 5G or one 5G link with multiple LTE links or any kind of combination like that. That will give you the best solution or the real solution of communication for any platform. Then you can utilize both 5G if you would like to, LTE, 4G, point-to-point, SATCOM, whatever you have on board. We are orchestrating all of those together into robust link.
Thank you, Yoav. So we have another question here. You're welcome, Shai, you're welcome to take it. In your opinion, what is the timeline regulation-wise to approving beyond visual line of sight fleets operating on a day-to-day basis like delivery services? And what are the main blockades to this reality?
So I don't think the term blockade is true anymore. We're actually flying beyond visual line of sight certified operations. So I don't think that the option is blocked. I think the idea is that there's an effort to certify the operation. It's obviously possible if we already did it. So basically, if you have your risk assessment or your SORA ready, then it's possible. And the system that flies it is a system that can be certified, taking into consideration communication loss, cases of communication loss, and how you make sure that you don't enter restricted areas, and how do you return home with no communication, and etc., etc. All these things that you have to make sure, then your operation is certifiable, and the certifiability of operations around the world is quite similar, using SORA as a basis and enough experiments and enough flight hours, it's certifiable.
Thank you, Shai. So this is a kind of question that we got here, which was actually pretty cool. So how would a UAV manufacturer benefit from working with either Elsight FlightOps or this joint solution? And what would be the differentiator between this kind of solution to what the market is doing right now or other market trends in terms of controlling drones beyond the visual line of sight?
So the first benefit is the benefit of a system that is actually capable of flying beyond visual line of sight autonomously, meaning with no or with less operators than the amount of drones. We are aiming to no operators, together with the robust communication that Elsight provide, then this is a formula that allows you to scale up your operation, add much more drones, fly further distances, and this is just a plug and play integration. You just add your bundle and add this bundle into your platform, and immediately you get a beyond visual line of sight, unlimited range, operate from anywhere, operate as much drones as you like, just by integrating this into your platform. So this is, to my opinion, the first benefit that you get. In addition, the ability that the fact that this platform was certified and is being certified in different parts of the world, then it is all the documentation required for certification processes and all the experiments required for certification processes have already been done. Then it makes it easier for certification. This year we have certified in Israel 16 operations to fly beyond visual line of sight with multiple drones. So this is a process that we are familiar with, and we know the requirements for it.
Maybe I will add to that, if I may. Like Shai said during the presentation, it's all about time to market. When you want to get to the market fast, it's going through regulation. And just like Shai mentioned, you want to make sure that you're going to the regulation phase with partners that already done this process and know how to walk you through this process. And this is very important because once you choose your partners, it will be very hard to go back. So going with those that already done and already paved the way, I think in terms of time to market and in terms of the ace of the process, that will be a no-brainer choice to do that.
We have another question here from Teresa. It's a little bit more technical, but she wants kind of to hear us sharing a little bit of the experience with working with either 5G or LTE. And the reason is that the ground antennas seems to not be designed to focus up in the sky. Is there any activity? Is there any activity from the ground to extend the antenna range from above 100 meters?
I would answer that. From our experience, which is basically thousands of flight hours, all of them on LTE. First of all, up until 100 meters, which is basically the most crowded area for drones, 100 to 120 meters above ground, we see really very few places that there's no coverage. If you climb up, and we fly operations up until 500 meters above ground level, and we still have coverage above ground level. When we entered the LTE world, we thought that it would be impossible to fly in these altitudes with LTE. The thing that we see, and the connection to Elsight solves this, is that in different areas you have different coverage of different networks in different altitudes. That's what happens usually, which means is you can fly with the perfect communication or perfect connection in one area, and when you go 2-3 kilometers away from this area, then you don't get this communication in this network when flying single network. And when flying with Elsight, we see that we get much better coverage, either for range or for distance of flight, and both for altitude. So to summarize, from our experience, although we know that today no operator would promise you that it would support air operation, we see that up until 100 meters above ground, there is usually if there is connection on the ground, then up until 100 meters there's no issue. And for distance purposes, we see that if you have multi-operator solution, then you solve this issue also.
maybe another point about the 5G. I mentioned it before that our approach is a little different. So speaking on the 5G new radio, like it's called, with the millimeter wave, the thing is that it needs to be, first of all, in line of sight, and it needs to be very close ranges because of the high frequencies. When you are talking from the telecom standpoint, they are obviously optimizing their networks to the average handset attitude. So that will be the street level probably. But when you're talking about LTE, that the coverage is much wider, and just like Shai mentioned, it will get you into high altitude, and on our test even much more than 100 meters. That will give you a cover. Not only that, but looking forward on the industry, and as long as the industry evolves and going forward, these whole cellular operators will start to look on this as another revenue generator for them, and by that creating the best infrastructure for that. And we see it happen right now. I mean, if you will look both in Europe and the US, you will see that the biggest companies who pushes this industry forward are the cellular operators, because they see great opportunity in this industry to create more revenue for their purposes. And where there is a revenue, we will find a solution. Like I said before, it's all about business case.
And I would add another thing to this to take into consideration, because when moving to autonomous onboard system coupled with the LTE system, you should change the way you think about data, or the data strategy delivered from the ground to the platform. The way we see it is that you don't deliver flight commands from the ground, like stick commands, and deliver back video. What you do is deliver basically the airspace information for the drone to make decisions by himself, and the goals or the missions that he has to do. For example, you would instead of having continuous flight commands for the drone, you would have a mission that would be the destination of the flight, and the data that you would deliver would be the spatial data, the area and the ground data to the onboard, and the onboard computer calculates the optimal routes to the point, and if it needs to change plan in the middle, then it changes the plan by itself, and it doesn't deliver back and forth data from the cloud or from the ground. So having this capability on board basically both allows you to use the cellular networks and reduces the dependency on either on connectivity and on bandwidth.
Thank you very much, Shai. We do have a triple question here from Marco. Marco, thank you for being so patient and waiting for us to answer. So I'll go one by one. Marco asks us, do the drones need modification? What is the hardware looking like in terms of weight and size, and is it certified for use in the US?
So I would say that going into sizes and weights, obviously we can send the specs and everything, but those two solutions together was specially designed for any size pretty much of platform that can be easily integrated. And like Shai mentioned before, that can be integrated into any drones that utilize either part of the DJI drones that Shai mentioned, and the Pixhawk drones. So basically there is no modification need on the drone side. Just need to have put it on board, connect the telemetrics or the sensor, and you're good to go.
Perfect. So another question here from Marco: are US SIM cards or data plan services allowed to be used for this commercial use?
Yeah, so this is a great question. They have different certification, special certification processes exactly for this use case. And obviously we are there to enable our customers to be connected. Part of them are still on the way, part of them are already built in.
Nice. And obviously question number 3, which would be interesting because I think this is the strongest part of combining FlightOps and Elsight. Marco is asking, will this solution work also at 1,200 to 1,500 feet?
Yeah. So You want to take it? You answer it before.
Yeah, it does. We fly these in certain operations. We fly these in these altitudes. I would have to say that it depends on the operators covering this area. But in most cases, I would say that we have rather good coverage. The thing is, as I mentioned before, the fact that you reduce your dependency on altitude. This doesn't have to do anything with either any LTE connectivity that you choose. The altitude of 1,500 feet is really quite the top limit for any LTE service, for any ground LTE service that you have. So you would like to have this same combination of onboard capability that reduces your dependency or the dependency on continuity, and the strongest or the most robust LTE capability coming from the Elsight LTE redundancy capability. So this is highly. We have a lot of experience flying these altitudes, and it's possible to do it with no problem.
Perfect. Marco is thanking us. Marco, thank you for asking the questions. So I think we are about done. We do have one general question that was sent out that I would like to go through. I would just like to mention before we do that, that this webinar is recorded. It's going to be sent to you as content about a week after the webinar. Also, you will be able to receive the presentation itself, the content of the presentation itself, and we will share that automatically with everyone who attended this webinar. I'll jump right into the last question. So generally speaking, how was 2020 in terms of COVID for your companies, and how did you overcome the obvious challenges?
I would say that obviously we are all hoping that the world will find the vaccine and we will start to see it over and the world will get over it. But I would look on the good part of it in terms of the unmanned industry as a whole, is that what it's bold, this whole COVID situation, bold the need for autonomous operations. It pushes the regulators to find a solution how to get us there. It makes people don't want to be close to each other, and that can be done by many parts of what we spoke today of different use cases with autonomy. So obviously we all hope for the day that we will be able to fly back in commercial flights and everything, and basically go out and free and being out of this whole crisis, worldwide crisis. But from the unmanned perspective, I think it was a great year.
Yeah, and I would add for that we see that the regulators all around the world are accelerating their approach to regulating UAVs. We see it here in Israel. We see it in the US and in Europe, and we see a lot of activity around this that makes it a promising future for this whole business.
Thank you very much. So just another reminder, you're going to get all the content information following this webinar. I want to thank everyone for joining, Yoav, Shai, and all the attendees that came here to listen to these insightful words from you. I hope this year is going to look, next year is going to look a little better than this year. So as we end this year, I do want to wish you happy holidays and that you have a great rest of your day and obviously a great weekend. Thank you very much.